Welcome to the introductory video of the course Intermediate Microeconomics, and welcome as well to the course Intermediate Microeconomics. My name is Adrian Soetervent, and this is the first of a series of online videos in which I will explain of every chapter of our textbook the main concepts. Watching the videos will hopefully assist you in studying the material, grasping the concepts, and also help you out in solving the exercises and assignments and help you to pass the exam. In this first video we will go over chapters 3 and 4 of the book, but before I will do that I will explain to you the organization of the course. So I'm the coordinator of this course and you will often see me online but also on campus, and I teach this course together with my colleague Francesco Febraro. So we both have an email address. Hopefully you don't have to use it a lot. Oftentimes if you have questions you can just ask them when we meet in class. You can also ask them during the break, but sometimes you feel a need to write an email to make an appointment to get some extra explanation. That's well possible. You can make an appointment by email and we will schedule either an in-person meeting or an online meeting. So the textbook that we will use in this course is the textbook Microeconomic Theory by Schneider and Nicholson. I hope you already have a copy of the book. If not, well, it's findable everywhere. Currently, the book has the 12th edition, but there are a lot of copies around of the 11th edition, so you may find them at an affordable price second-hand. It's not a problem if you have the 11th edition of the book, because it's more or less similar to the 12th edition. Maybe you will find that some numbers of the exercises are slightly different. In this course we will have 3 meetings every week. So we will have an online lecture like the one that we have right now. And on top of that we will have in most weeks 2 hours on-campus lectures. And I'm very happy that we're able to meet again. And the on-campus lectures are mostly organized on Monday and Wednesday. So for the online videos, if for example the online video about chapter 8, if we need to study chapter 8 in week 20, then I will make this video available somewhere at the end of week 19, such that you have ample time to watch the video before the week starts. For the on-campus lectures, what will we do there? So in most cases we will either run through a couple of exercises from the book. So I will, you need to prepare them, you need to solve them and then come to class, and then we will go over the exercises together and solve them. And in the other on-campus lectures we will not do exercises from the book, but we will go through exercises that originate from old problem sets or old exams. So you will get ample opportunity to practice in this course, which also hopefully will help you to pass the course. Now, what do you need to do in order to pass? You need to get a passing grade, and the details about the grading, how the different components are weighted till your final grade, it's all described in the course online, which you can find on Nestor. The course outline is a PDF document of 5-6 pages, and actually that course outline contains all the details about the organization of the course. So print that document or at least download it and you will have all the details about the organization of the course. There will be 2 problem sets, and for the problem sets there are 2 deadlines and you need to hand them in before the deadline. And the first deadline is at Sunday, May 29. And the problem sets are already available online, so you can download them today. And you know that it's not yet May 29, that's still quite some weeks off. So you have the opportunity to really plan working on the assignments at a time that suits you. And I really can recommend not start just before the deadline, because then you will find out that you started too late. And also the deadlines of the two assignments are pretty close together. They are both near the end of the block. So it may also pay off not to focus on problem set 1 before May 29 and then only start working on problem set 2, but also to already pay some attention to problem set 2 in the coming weeks. And you should hand them in by uploading them in the student portal. Fortunately, you don't have to do the problem sets alone, because it's a group assignment and you need to form groups. And for the problem sets, groups need to consist out of at least 3 and maximally 4 persons. And I encourage you to find your own group mates. So look around, make phone calls or app people that you know who also participate in this course, and try to construct a group of 3 persons or a group of 4 persons. If you have created a group yourself, then inform me about the composition of your group by sending me an email. And in that email, please list the names and the student numbers of all group members. Of course, it's also possible that you cannot find a group, or you team up with one of your fellow students, but your group consists of only 2 people and you need 1 or 2 people more. In case you cannot find a group or your group is not complete, then please also send me an email informing me about that. Do this ultimately on Monday, April 25 before 4 o'clock in the afternoon. And then I will search for group members for you and make your group complete. In both cases, either if you find a group yourself or you are looking for group members and let me do the composition, in both cases you will need to complete a survey, the Team Maker survey in Academy, and you need to do that before Tuesday, April 26th. And in order to complete that survey, you will receive an invitation by email. And also, students who have formed their own group can only complete this survey after they have received the group number from me. So if you form your own group, inform me about the composition of your group. I will give you a group number, and once you've received your group number, you can fill out the Academy survey. The problem sets are a once-in-a-lifetime opportunity, unless you repeat the course next year, which hopefully you don't. But for the problem sets, there are no repeat opportunities. And for further details on the group composition and the assignments, also see the course outline. As soon as you have formed your group, you can start working on the problem sets, because the essay assignment is already online. And again, we have selected 2 great papers that have been recently published in the top economic journals. And it's your job to select one of the 2 papers and to write with your group an essay about that paper, answering in your essay the questions that we have formulated. And there are 2 really nice papers. The first one is by Imke Rijmers and Jo Waldvogel, called Digitization and Pre-Purchase Information. And this paper starts with the observation that books are an experience good. That means you only find out the quality of a book, whether you like it, once you've read it. But it's very hard to know beforehand whether reading a book is worthwhile your time. Of course, what can help is to read the reviews by other readers. So to read what they liked or particularly disliked about a book. So with the advent of the internet, more and more reviews have become available. And especially many books now receive a star rating. So if you visit Amazon and you look at the books that are sold on Amazon, that you often see a number of stars accompanying a certain book title. And what Waldvogel and Rijmers do is they look at these Amazon book ratings and they measure whether the Amazon book ratings have an impact on the sales of certain titles. And not only that, they also consider the consumer surplus. So you can imagine that if you compare a situation where these online book reviews are available compared to a situation where they are not, then having this additional information will allow consumers to better match their preferences with certain book titles. So you don't lose as much time reading these useless books as you did before. That may be the benefit of the availability of online book reviews. So what Rijmers and Waldvogel do is they build a structural model to really evaluate, to measure the added consumer surplus of these online book reviews. And they also compare the online book reviews, so the Amazon star ratings, with the reviews in traditional outlets like the New York Times. And what they find is that the impact of the online book reviews is 10 times as large as of the traditional book reviews. The reason being that there are many more of these online reviews. So their aggregate impact is much larger. The second paper is about the gig economy. And as you can see, one of the authors is Joshua Angrist, who won the Nobel Prize in Economics last year, together with David Card and Guido Imbens. And what they study in this paper is cab drivers and their labor supply. So traditionally, if you want to drive a cab in a city, you need to buy a medallion, which is very expensive. So you pay a lump sum, but then you have the opportunity, a license to operate a taxi in a city. But the upfront cost is particularly large. But once you have that medallion, then you can keep all the revenues of the trips that you make with your car. Nowadays, you have a company called Uber, and the Uber drivers, they don't have to buy a medallion, but they need to pay a commission fee to Uber for every trip. So they don't have to make this upfront investment, but for any trip that they make, they have to pay a fraction to Uber, and there are less revenues left to the cab driver. So what Angrist and co-authors do in this paper is that they run a field experiment where they offer a random group of cab drivers a virtual medallion. So they can buy this virtual medallion, which helps them to eliminate the Uber fee. Now, for some riders who don't do a lot of trips, this is not very attractive, but you can imagine that for cab drivers who do a lot of trips, it's very attractive to have the opportunity to keep all of the revenues and not to have to pay Uber a commission on each of these trips. So they look at who buys the virtual medallion, how much drivers are willing to pay to get rid of this commission fee by Uber, and whether they also make optimal choices. So that's the second paper, which is really a nice read and also brings compensating variation and equivalent variation to life. It's up to you which one you choose. They're both great papers. Later this block, I hope to have an interview with Imke Rijmers, so one of the authors. She's currently working at Northeastern University, and I'm going to talk with her about this paper. So how she did it, the difficulties that she faced when executing this research, but also to talk with her about research in general. So what is her motivation to do economic research and to do quantitative economic research? What brought her to the US? And I'm very much looking forward to interviewing her, and I hope that you are looking forward to this interview as well. I will keep you posted. Okay, then the online resources for the course. The assignments can be found in the folder Assignments. What a surprise. Then the course information, including the course syllabus, can be found in the tab Course Information. And please read the course syllabus carefully, because that's the one document with all the important information. And you don't want to miss out on anything of that. And on the course information, you can also see a link to the discussion forum on intermediate microeconomics, and this is also part of our online context. At the discussion forum, you can ask questions, and I encourage all students to actively participate, to ask questions, and also to answer the questions of other students. And also, once a week at least, I will visit the forum and see whether there are any pressing open questions that need an answer. Then the online lectures, you are here, so probably you found the position of the online lectures. But the online lectures will be uploaded 1 week in advance in the tab online lectures. And then you find 2 documents. One is a folder with the slides of that lecture, and then the second one is the video. Then also students find it very important that there are old exams. Well, I will upload some old exams in the folder old exams. And first I will put them there, exams without answers, such that you can practice. But near the end of the term, I will also post the answers to the questions. And these answers are quite detailed, so if you read them, you will see what you had to do and you will learn from it. But please try them yourself. Okay, what is the position of this course within the broader spectrum of your education? This course simply builds on 2 other microeconomic courses that you already attended. The first is the first year course, Microeconomics, Consumers and Firms, where you studied perfect competition. Everyone is a price taker, no one had market power, no externalities or public goods. Perfect information, everyone knows everything, and everyone also acts fully rationally. And then in year 2, you had Microeconomics, Industrial Organization, where the assumption of perfect competition was lifted. And you studied monopoly and oligopoly and what happens if firms do have market power. Now, what are we going to add in this course? We're going to dig deeper, and mathematically we will be much more advanced than the first year course. So a lot of the concepts will be familiar to you because you already learned them in your first year, but now you will study them more in depth, which implies more and more advanced math. And we also address a number of additional questions that were left at the side in the first 2 courses. What happens if there's asymmetric information, if not all parties involved in a market transaction have the same information? How do agents deal with risk and uncertainty? So far you didn't deal with risk, but most real-life environments are uncertain. And we also do this in strategic settings. So when each agent is not small compared to the market. So we also will study some game theory with mixed strategies. And I include empirical studies such that it will not be too dry, I hope, but you will also learn about what applied research is, how economists apply these tools in daily practice, working with data. And I hope that this will all deepen your understanding of microeconomics also as an approach. Now, what are the building blocks? Today we will talk about preference and utility. The first 3 weeks we will focus very much, like in the first year, on the consumer side and do consumer theory. Then we will switch somewhere halfway week 3 to the supply side and delve into the equilibrium concepts in week 4 and 5. Now, all that in another form you had in your first year course. And as of week 6, we will also introduce new concepts with uncertainty and game theory. And we will do a part on asymmetric information and do a little bit of auction theory there. Now, then there is more, except or besides these 3 microeconomics courses. Some of you will be near the end of their studies. For them, it will be the final course, which is great. For other people who will also be around next year, if you like this, you could contemplate taking courses, minor courses in environmental and resource economics, where externalities are studied, or the minor in behavioral and experimental economics, where the main question is, okay, what happens, what are the outcomes if people do not behave rationally? And that includes also experimental evidence. So how to design a good laboratory experiment. Now, then in the master, once you've completed the bachelor, if you continue with the master in economics, you can again take a number of follow-up courses in microeconomics, including games in industrial organization, more on firms with market power, competition policy, which also deals with how to regulate the big tech firms, for example. Should we do something with Google and Facebook? The economics of regulating markets, so also the energy market. You have, how should governments deal if there's a natural monopoly? Then there's a course in public economics and social policy. So how should government establish fair outcomes in society? How should public goods be allocated, and who should pay for them? And how should externalities be addressed? And there's the economics of household behavior, which looks at the intertemporal setting. So you don't have one period, but you really look at your entire life cycle. So how do you save for retirement? How forward-looking are people in their planning, in their savings decisions? And in that course will then again also include insights from behavioral economics, that people are myopic, that they sometimes do not look that much to the future. Any one of you already thinking about his or her pension? Probably not. According to the life cycle hypothesis, you should. And finally, besides the master in economics, suppose that you are really into research. So reading the papers of the essay assignment, you think, oh, I really would like to do applied research at a high level myself, and maybe also do a doctorate and obtain a PhD. Then you may also consider subscribing to the Research Master, which is a 2-year program, which has the advantage that there's more time to really go deeper into economics, and also economics as a science. And you really get fundamental econometrics training, and with the objective to pursue a PhD afterwards. If you're interested in that, I'm happy to give you a little bit more insights in what the Research Master is. So please send me an email. Now, further preliminaries to the course. Chapter 2 in the book contains the basic math. So you might not feel very secure about your math qualities. If that's the case, please reread chapter 2 in order to get your knowledge up to date, and you will be fine. So if any the rules of differentiation, integration, constraint optimization, and the envelope theorem, if you question whether you fully master these things, then maybe it's good to have a look at chapter 2. So before we go further into the deep, we need to address the basic question, what is microeconomics? And we also have to set some limits on the scope of our studies and the scope of the field. And the basic observation that underpins microeconomics is that we study decision-making under scarcity. Individuals and firms, they face a limited amount of time or money or both, and they have to make tough choices, and they have to make trade-offs, what to do, how to invest. And that's what we study. So as an individual, you have to decide when to watch these lectures, and the trade-off is doing it during the day when the sun is up and the weather is nice, or to do it in the evening instead when the opportunity cost of watching videos may be lower. But maybe your attention is also less, so you need to re-watch them. And in a broader perspective, you have to choose whether to attend college, whether to work instead, how much time to invest in your studies, how important time spent studying and getting ECTS is compared to investing in your social network, and so on and so on. So that is what we will do. And the firms, as said, they also face constraint. They have to choose their inputs that they use in the production process, and then given the inputs, labor, capital, they have to decide how to use them in an optimal way. And we will go into both in the course of this study. Given that we face constraints, constraint optimization techniques are important in microeconomics. So now basically, but this is not new to you, for most goods there is a market where the good is exchanged against the price. So if you buy the good, you get the exclusivity of using that product. And we study the choices that individuals, firms, but also the government make, and what impact these decisions have on markets. And we do so by formulating models where we impose some kind of rationality onto the agents. And so this makes economics what Breit and Elzinga call the unique discipline whose practitioners, unlike those in the other social sciences, are mainly engaged in solving behavioral puzzles through rational theorizing. And of course, within economics, or to some extent also outside economics, there's this discussion to rethink economics, saying, okay, the training in neoclassical economics is bad because it leaves a lot of things out of the picture. And also the rational theorizing is attacked. And what I want to do next is to inform you a little bit more about, okay, what is rationality as we impose it, and also what is included and what is not. So the approach here is that we observe people making certain trade-offs in real life. We observe them doing something, and we try to explain this behavior, first of all, by rationality and assuming that there's a rational explanation for what they do. And this is not unlike research journalists at Follow the Money do. So they also observe firms behaving in a certain way, engaging in pollution, and so on. And they ask the question, okay, what is the rational explanation for why we observe firms acting in a certain way? What incentives drive their behavior? And that's also the approach that we will use here. So we are in the position of Sherlock Holmes, who has to solve a murder and then looks for rational explanation who could have had an incentive to murder that or that person. So, and that's in general in detectives, that's very fruitful, because most of the time, in the end, there is some affair going on, or it's money that drove someone to engage in the act of murder. And it's much more fruitful than to go for other more esoteric explanations like, oh, I guess that this person has been murdered by person Y because that person dislikes people with red hair or something. So that's not what you want to do in the first place. And it's the same in economics. So if you have a neoclassical microeconomist looking at individual actions, then the starting assumption is that the individual acted in that particular way because he was driven by incentives that guided him or her to maximize his utility in that situation. And we're rather abstract about what the utility function is. So we have a lot of degrees of freedom there. So it's not that individuals are always selfish. You can also incorporate altruistic motivations into the utility function. And then we take the analysis from there. So we try to back out what the underlying preferences of that individual might have been that resulted him or her to act in that particular way. And Breit and Elzinga, who were quoted in the previous slide, were two economists who also wrote a couple of novels in which they explained also murder cases using economic tools. So one of their books is called Murder on the Margin, which also used the concept of marginal utility to solve a murder. Now, some decision theorists go very far in that, looking for rational explanations. So, for example, drug use. Using drugs in excessive ways is really bad for someone's health, and it shortens your expected lifetime. So you might say if you observe someone using drugs, then that person does not act in his or her own interest. So apparently it's a clear case where the person is not optimizing his utility, because otherwise you would never engage in using drugs. However, a decision theorist may argue, well, we have to look for a rational explanation, and there may be very natural explanations for this type of behavior. Like David Levine, he argues, well, suppose now that you're poor, is it then so irrational to use drugs? If the alternative is to live in miserable poverty and to observe that you are in miserable poverty, then it may become, in this trade-off, very attractive to use drugs and to escape to the drug-induced fantasies. And that fantasy doesn't sound that bad to me, given these dire circumstances. And that gives you a different perspective. So it's not maybe, this is maybe what you should do. Not first, if you observe a person using drugs, saying, oh, that cannot be good. That person doesn't act in his own interest, but also look for the deeper motivations for why that person chose that particular type of action. And that may be much more fruitful. And that can also be the starting ground to say, well, we need to improve the circumstances of these people. So and what do we mean by the optimal choice of an individual or a firm? So it's the choice that maximizes the utility of a person, or in case of a firm, that maximizes the profit of a firm. And that brings us to the next question: what is the utility? And the utility, that's a rather broad concept, and you can really incorporate a lot of motivations into the utility function. So also when it comes, so neoclassical economics is often described as something that's very narrow in terms of the utility function, but in practice you can take the utility function rather broad. Now, the utility functions, they represent individuals' preferences, so we first need to talk about these preferences, what preferences people have. We will do so in this lecture, and then in the next lecture we will focus on the constraints which are imposed by the budget, the money that the person has available, and the prevailing prices in the market. As said, we study individual choices. That's really rather broad, and economics has also been called imperialistic because of that, and it's not without reason, because our methodology allows us to study a lot of different choices. Now, we will focus on consumption choices and production choices, but these are not the only ones. So it can be applied to many choices, and Gary Becker, who won the Nobel Prize in Economics in 1992, he played a pivotal role in extending the domain of microeconomic analysis. So he made it much more interesting by also looking at a lot of non-market choices that people make. So to give a couple of examples, he started out in his career studying crime and punishment. So you need to make a trade-off whether to engage in a crime or not. Now, if you're well off, then you don't have a lot of incentives to risk all that you have by starting a burglary. But again, if you are poor and you have no way to make a living, then it may become attractive to engage in criminal activities. Whether you will do also depends on the punishment and the probability of getting caught. And in his early work, he studied a lot this optimal trade-off. Should you have high fines with a low probability of getting caught, which is nice because you don't need that much police around, or is the deterrence effect larger if you have a lot of police around, which is costly, but the fines are on the lower end. So what is the optimal fine for a crime? That's a question that you could address. Discrimination against minorities, which all economists consider a bad thing for many different reasons. It can also be a moral reason, but also because a lot of potential is lost if people don't get the opportunity to fulfill their ability. And he looked a lot into human capital formation. So how do people invest in their own human capital? How do they decide how many years to study, whether to enter higher education? How is it affected by college fees or in subsidies and the wage that they can earn later in life? And also, he took it even broader. So he also studied choices about the family. So the marriage market. Now, you might not normally look at finding a spouse or a partner as being part of a market interaction, but his research has made clear that you don't choose random a partner. You do have incentives to look for a partner where the trade-off is how friendly and how attractive is this partner, but also what opportunities do this partner does the partner give me in fulfilling my own career opportunities or in the life that I want to live. And it turns out that you can say quite a bit about that. So one example is that nowadays there are more women with higher education than men. So a lot of higher educated women have problems with finding a higher educated partner. So there are many books about that. Also, fertility choices. How many children does a couple have? Turns out that's quite a rational choice, and even the size of the car seems to matter. So if you go from 2 to 3 children, then one thing that you will face is that if they are in a close age range, then all the children safety seats no longer fit in the back of your car. And research has been done showing that this has impact. The safety regulations in cars have impacted the number of children that people will have. The impact is not that large. It's not overruling everything, but there is some effect. And a bigger impact has Because of contraception, women have fewer children, which allows them to have more of a career. And that has changed the entire household interaction. And you can think of many, many more topics here. What I wanted to tell you is the approach that you learn in this course, and we will focus on consumption and production choices, but they can also be used to analyze this broader set of choices that people make. And now, in the past, few people divorced for the simple reason that for women it was particularly unattractive to divorce because they could not live outside of marriage because they didn't have jobs. Nowadays, women are much more independent, which has led to much higher divorce rates. It become easier for them. The trade-off has changed. So, yeah, then of course you can. A question that naturally comes up is, okay, do we really think that people maximize their utility? Are they really these walking calculators that every time that they have to make a decision, make an explicit calculation on what to do? Do they really consider all alternatives available each time that they have to make a choice? And is our representation by mathematical models really super realistic? The answer to that is no. People in practice, every time you drink a cup of coffee, it's much more likely that you don't think deeply about it, that maybe you also use a heuristic. But in many of the important choices that we make, it's clear that we act as if we would optimize a utility function inside our mind. We don't do it explicitly, but our behavior can be quite reasonably explained by assuming that we do. Now, that is the famous Milton Friedman's pool players analogy, where he says that pool players, every time they take a shot, they don't take into account the Newton laws of gravity and motion, but they play as if they follow these laws, because they, by experience, they know quite well what will happen if they take a certain shot in a certain way. So that model can explain their actions. Now, there's been a long discussion about this analogy, and I want to give you a couple of comments on it. So Richard Taylor, who won a Nobel Prize more recently in behavioral economics, he said, well, economics is supposed to be a theory that describes the behavior of most people, all people, and not only the experts. And the pool players in this example are experts. They play pool 5 hours a day, 20 years in the career. And the point that Richard Thaler makes is that learning from experience is sometimes difficult in economics. So buying coffee at a coffee corner is a decision you often make, and at some point you have the experience, you know which coffee you like best and how to optimally make this trade-off. But there are a lot of decisions in real life where we don't get that experience. So in behavioral economics, there's attention for that often people find themselves in a choice context that is unfamiliar to them, and when the choice context becomes less familiar, they are less prone to not making the optimal choice. And even if they get more experience, some of these suboptimal decisions may persist. And in the essay assignment, you will see examples of that. Now, Colin Cameron, another behavioral economist, he makes another point, and he says, well, the pool player acts as if he or she knows geometry and mechanics, but even that as if assumption may predict badly when the conditions change. So you have a warp table, the balls are lighter, the pool player becomes fatigued, and he as if optimization assumption needs to come from somewhere. So it's experience by learning, it is due to evolution, due to the pool player being trained or imitating what pool players have done before this pool player. So Camera says, well, we need to also pay attention to the reasons for this as-if assumption. Where does it come from? Is it because of evolution, because of habit formation, imitating other people who have done so before? And he has a couple of slides which are also quite interesting. In the end, all theoretical models are based on unrealistic assumptions, and the ultimate test of a model comes from when it's confronted with data. So important in all that we do, all the assumptions that we make and the theories that we build on it, is does the model make predictions which we can also falsify? And if yes, I mean a good theory needs to be falsifiable. Then if the theory predicts well, then it's a nice result and it's a very helpful theory. If the predictions are bad, then probably there's something wrong with the assumptions. So that's the way to proceed and to make progress. So we need to test our models with data. Finally, it's useful to know that the discussion that neoclassical theory is way too simplistic, leaves out a lot of things that matter in practice. That discussion is not new. Already in 1953, Milton Friedman, who can be seen as the neoclassical economist, writes that there's a perennial criticism of orthodox economic theory for being unrealistic, and that attempts need to be made to reformulate theory to meet this charge. And the traditional complaint is that economics is a dismal science because it assumes that man is selfish and money grubbing, a lightning calculator of pleasures and pains, and it rests also on an outmoded psychology and must be reconstructed in line with each new development in psychology. And that's the criticism that you often hear, and Milton Friedman is also not liked for his neoclassical approach, but it's often ignored what he writes next, where he says that, as we have seen, criticism of this type about the accuracy of the assumption that we make is largely beside the point. And here it comes, unless supplemented by evidence that a hypothesis differing in one or another of these respects from the theory being criticized yields better predictions for as wide a range of phenomena. And I think that with behavioral economics having become mainstream, this is really the point where we find ourselves, that economics as a field is very open to add additional assumptions to the models if they increase the predictive power of that model. But that is the ultimate litmus test. And already in 1953, Milton Friedman concedes that as well. We should not incorporate all aspects of reality, but if there's evidence that this additional realism helps to improve our predictions of how people act, then it's useful to do, and we should do it. Okay, then some actual things from daily practice, also because it's fun. At Google Trends, you can look real time what people look for on the internet, and you can also download those data and make pictures of them, and it gives you a real-time snapshot of the economy and people's motives, how they spend their time and money. Although these are indirect indicators. I mean, searching for something is not directly that you also buy something, but there tends to be a strong relation. So last year, around this time, I showed to the students what happened to the internet search for the search term restaurant, and we just entered the lockdown, and you can see that has had a huge impact on the popularity of restaurant as a search term on the internet. So there's really a severe drop in March 2020. Now, how did things develop as of then? This is the most recent 2 months. You can see that in the summer of 2020, searching for restaurants became popular again, and that coincided with the lifting of the lockdown. Restaurants were open. They closed again in October 2020, and that again has been reflected by less people searching for restaurants on the internet. Now, that's not rocket science, but it's nice to see how you can use Google Trends as an indicator for real life economic activity. And if you take the long term perspective from 2004 to 2021, you really can see how special the times are we now live in. So there was really a gradual increase in searching for restaurants on the internet because, well, more and more people started to use internet until the COVID pandemic hit. Now, if you don't go to a restaurant, what do you do with your time? You can also consult Google Trends to get some indication of that. I did that for paint. How many people look on the internet for paint to renovate their home? And what you can see is in March 2020, together with the lockdown and the restaurants being closed, indeed, there was a huge jump in the number of people that looked for paint on the internet. So already then we had a signal that people would spend more time and money on their private home. And that has been later been backed up by the data showing that indeed the do-it-yourself stores had a very good time. So, but Google Trends as an early indicator. Now, how did it continue? We are still in lockdown, and there is some demand for paint according to Google Trends, but we don't see the excessive jump that we saw last spring. Now, people respond to incentives. That's the central theme in our course. And one question that you can ask is, okay, if you increase the excise duties on fuel use, how do people respond, and do they respond to that incentive? And what you can see is that the excise taxes in the Netherlands is higher than in the surrounding countries like Germany and in Belgium. So what people do who live close to the border, and maybe you or your parents do, people who live close to the border, they find it attractive to buy their fuel just across the border in Germany or Belgium at a lower price. So indeed, people respond to lower prices. Interestingly, firms, they also respond to incentives. So here's a US example. So in 2008, when we had the financial crisis, then the gas prices started spiking, and the traditional car companies, they were in trouble because they had all these big cars that they sold, these gas guzzlers, and when the prices of fuel increased, people respond to incentives. Consumers, they switched to buying smaller cars instead, and the traditional manufacturers did not make that type of car. So what you can see is that in 2008, we have the fuel price over here. So that was just before the financial crisis hit. Fuel prices went up, and people bought more and more smaller cars, decreasing the market share of the traditional manufacturers. So people respond to incentives, but in the end, firms do as well. Because in 2012, There's another increase in the fuel price. So we had the financial crisis, the fuel price dropped, but then after the financial crisis, they gradually increased again to the 2008 levels. But you do not observe in 2012 the same drop in the market share of the domestic car producers. You see that it remains rather flat. Because in the meantime, the car manufacturers also responded to incentives. They had started making smaller cars. So in 2012, they were not hit by the higher prices as before because people could still buy at the traditional manufacturers the smaller cars. And this is strong evidence that if you just hike up the fuel price, then firms will switch to manufacturing more fuel efficient cars, and consumers will also demand that type of cars. So the market is able to flatten things out and to arrive at a new equilibrium. So to summarize, microeconomics can help us to understand the behavior of individuals in firms. Maybe not all, but at least important decisions we can shed our light on. Now, you also can address questions like, okay, if you give assistance to the poor, not by just giving them money, but by giving them in-kind transfers, such as food stamps, what happens? Do they spend more of their budget on food? So if you want to do something for poor people, then there are two things that you can do. You can just give them money, but then you might think paternalistically, okay, if we just give them money, they may not spend it on the things that we would like these households to spend the money on. So maybe they go instead buying cigarettes, which we don't really approve of. So instead, we might give them food stamps, which are labeled that people can only spend them on food. But if the poor household acts rational and they already spent, say, $50 a week on food, and now they get food stamps that allows them to buy $30 of food, then the rational thing to do would be, okay, now I use not my own money to buy food, but I use the food stamps and then $20 of my own money. And then if I want to buy cigarettes, I can use the remaining $30 to buy cigarettes. So in practice, for what people do, it should not matter whether you give the money in the form of money or in the form of an in-kind transfer. Now, evidence shows that in practice, it does matter. If people receive food stamps, then they increase the budget share that they spend on food. So, other question is, okay, if people act rational, does it also imply that they act selfish? Or can altruistic behavior also be part of rationality? We will get to that. And why is it better to have relatively high income taxes and low taxes on consumption goods if the labor supply doesn't respond to changes in the income tax? That's one question that we will also address. How do people deal with risk, and what contracts will insurance companies offer to protect consumers against risk, and what premium will they charge for their policies? Now, why is it hard to find a decent car on the second-hand market or on Marktplaats? How do professional soccer players play penalty kicks from a game theoretical point of view? So that was a real long introduction to the course. Now we will start with chapter 3. And chapter 3 discusses preferences and utility functions. And a preference is simply a relation that describes how the individual evaluates one alternative over the other. And in practice, he can compare many pairs of alternatives, and all these alternatives come from something that we call the individual's choice set, or the set of alternatives. And we denote the set of alternatives by the capital X. And every time when in the slides I use this musical note, then I mean that a definition of a concept is given. And the boldface X that is part of this choice set X is a vector or a bundle denoting one particular alternative. So we think of alternatives as a bundle of different goods. Now, to give one example, always dealing with apples, bananas, and or other fruits. Suppose we have a three good economy, then one bundle may be bundle Y, consisting out of 2 apples, 1 banana, and 3 oranges. So that's the notation of alternatives in a choice set. Now, and for convenience, because the vertical notation takes a lot of space, we will write this vector mostly in row form with a tilde or with a prime to denote that actually it's a column vector. Preferences are described by this particular symbol, and whenever we write X is weakly preferred over Y, it means that the individual finds bundle X at least as attractive as bundle Y. So X is weakly preferred to Y. And from this relation we can derive 2 other relations, one being strict preference. So we can write X is strictly preferred over Y if and only if X is weakly preferred over Y, and it doesn't hold that Y is weakly preferred over X. So you can see that the strong, strict preference relationship can be defined in terms of the weak preference relationship. Also, we have a third relation called indifferent. The individual is indifferent between 2 consumption bundles, X and Y, which is indeed noted in this way, and can also be defined in terms of the more basic weak preference relation. Because a person is called indifferent between 2 bundles X and Y if he weakly prefers X over Y and at the same time weakly prefers Y over X. And the key assumption in neoclassical microeconomics is that these preferences are rational. So what do we mean by that? Now, not a lot, at the same time, quite a bit. So preferences are called rational if both completeness and transitivity is satisfied. And now the follow-up question is, what do we mean by completeness and transitivity? Well, completeness says that if we have 2 alternatives in a choice set, that it either must be that the individual weakly prefers bundle X over Y, or he weakly prefers weakly Y over X, or both, in case in which he or she is indifferent. This implies that as soon as we make this assumption of completeness, it requires that the individual has really well-defined preferences between any possible alternatives. So I give the individual 2 random alternatives. Completeness says that the individual is able to tell me whether he weakly prefers one alternative over the other or is indifferent between the 2. Now, in practice, this can be quite daunting, this task of in this completeness assumption. Consider, for example, the ice cream selection of Ola. Then you can see, well, about 20 different ice creams. Completeness assumes that if you face this selection, that for each 2 ice creams, you can tell me whether you weakly prefer one over the other or are indifferent between the 2. Now, in practice, it may be that you never thought about buying a Calippo because you always choose a Magnum. But even within the set of Magnums, you may find it hard to really indicate whether you prefer the classic to one of the alternatives or not. So it can be demanding in practice, but nevertheless, we make this assumption because otherwise we run into other types of problems. That's one. So then the question you may have is, okay, but sometimes I prefer an umbrella over sunscreen, and other times I prefer sunscreen over an umbrella. Am I irrational? Because it's not true that I always have the same preference relationship. Now, the answer is no, this is not irrational if you define the alternatives properly. So, in many cases, you are helped by thinking of a commodity under different circumstances, like sunscreen on a sunny day is a different good than sunscreen on a rainy day. And yes, you may prefer sunscreen on a sunny day to an umbrella on a rainy day, whereas on a rainy day you may prefer to have an umbrella over sunscreen. So you can solve this problem, the apparent conflict between your preferences, by defining the choice set, the alternatives, in the appropriate way. Second condition is transitivity, which says that if we have three alternatives, x, y, and z, then if the individual weakly prefers x over y and prefers weakly y over z, then it must be that he also weakly prefers zx over z. And this is helpful because this avoids that the preferences of people cycle. So this prevents that we observe an individual choosing x over y, then y over z, but then at the same time preferring c over x. So that cannot be. So we should be able to order the alternatives from top to bottom. Question: do you think this is what non-economists typically mean by rationality? Now you can answer the question yourself, but these two conditions are not that remarkable, I would say. We only assume that people are able to say what they prefer among a set of alternatives, and that they are able to rank the set of alternatives. And that's all we need, and if that's satisfied, preferences are called rational. Second question: what is a utility function? Utility function maps from the set of choices to the space of rational numbers. And the utility function is a representation of the preferences. So if the utility of an alternative x is at least equal to the utility that the person derives from the bundle y, then it must be that this person weakly prefers x over y. So the utility functions allow us to move from describing preferences in terms of binary relationships to expressing them in numerical terms. And that's very helpful because that allows us to make computations. So this is what we want, but the question is, can we always find a utility function that exactly matches the preferences, underlying preferences of the individual? So an example of a utility function is this one. We have two goods x and y. The non-boldface x denotes the number of units of x that we consume, the same for y. And here it turns out that if you have one unit of x and 1 unit of y, it gives you a utility of 1. If you have 1 unit of x and 3 of y, your utility is 3. And if you have 2 of each, your utility is 4. It follows from this utility function that the underlying preferences must be that you prefer having 2 of each good strictly over having 1 of good x and 3 of good y. And you prefer that again over having 1 unit of each. Now, why is rationality such an important assumption? Answer to that question is rationality is the key in making the translation between utility functions and underlying preferences. Only rational preferences can be represented by a utility function. So if preferences are not rational, we cannot present them by a utility function. And that is the reason that rationality, these two, transitivity and completeness assumptions, are so important. I don't give a formal proof here. You can find it in a more advanced textbook by Mascolel. And it also means that if we can represent someone's preferences with a utility function, so if the utility function gives the same ranking as the underlying preferences, then the preferences of that person must be rational preferences. Can any rational preference ordering be represented by a utility function? That's another important question. So suppose that a person has certain preferences for pairs of consumption bundles. He knows how to rank all of them, and he can tell the economist whether he weakly prefers one over the other or is indifferent between two alternatives. Can we then always find a utility function that represents those preferences and exactly those preferences? And the answer is no. Rationality is not a sufficient condition. We need some additional conditions to guarantee the existence of a utility function. And we will come to those assumptions next. So it works one way around, that if we have a given utility function and we can represent the preferences by a utility function, then those preferences must be rational, but not all rational preferences can be represented by a utility function. And we need a couple of additional assumptions, and one of them is continuity. And continuity means that if an individual strictly prefers a consumption bundle which gives them x1 units of good x and y1 units of good y over another bundle that gives them x2 units of good x and y2 units of good y, then it also must be that if we take an arbitrarily small amount of away from the bundle, from the first bundle, so we take away epsilon units of good x and epsilon units of good y1 from the original consumption bundle x1 I1. If this amount epsilon is arbitrarily small, then it must continue to hold that also that bundle is strictly preferred over the bundle x2 y2. Why is this helpful? Well, if we impose continuity on the underlying preferences, then it says that the individual preferences cannot jump. So the preferences must be fairly gradual. So continuity deals with limit situations. Now, suppose that the preferences of an individual are rational and also the continuity axiom is satisfied. Then there is a continuous utility function that represents these preferences. So what we need, if the underlying preferences are rational and satisfy continuity, then we can always find a utility function to represent those preferences. And again, I don't give a formal proof. It is important to note that what we study is what is called decision utility. So we use utility functions just as a way to summarize decision preferences. So it allows us to summarize how people choose between two alternatives. Not more, not less. And if you take this in a historical perspective, this is a departure from some history, because in the late 1700s, people like Jerry Bentham didn't use decision utility, but they used experience utilities. So they had the idea that you really could measure the number of units of pleasure or pain that people would derive from a certain situation or consuming a certain alternative. Yeah? And this is related to notions of happiness or hedonics. So, how much pleasure or pain do you derive from a certain alternative, consuming a certain good? And that is a very absolute view of utility, because then, okay, you can measure how many units of pleasure a person receives from one cup of coffee, and you try to measure how much additional units he or she receives from having one more cup of coffee, and so on and so forth. That enterprise ran into quite some problems. So, one of the problems is that it's really hard to do these type of measurements. You can hit a person with a hammer and then measure the number of units of pain that this person feels, but you don't have a clear unit of measurement. So should you go for the loudness of the scream? It's really unclear. Second problem is interpersonal comparisons. If you hit a person with a hammer, one person may scream, the other person may scream less so. How to compare the units of pain or pleasure of these two persons. So it was very hard using experience utilities to make interpersonal comparisons. And that project has been abandoned, although recently, with the advent of the field called neuroeconomics, where people can measure what happens in the brain of people when they take certain decisions, some measurement is possible in the form of, if people take a decision that costs them money, they can see whether the part of the brain that has to do with experiences of pain, how much that part lightens up. And the more it lightens up, the more pain the person is measured to feel from taking such a decision. Same for pleasure. So neuroeconomics is some backdoor into this enterprise, but it continues to be pretty daunting. So in the 1870s, a new approach arose, and this is the famous marginal revolution, instigated by people like Jevons, Menger, and Walras, who said, well, we don't need to measure the absolute utility levels of people. We don't need to have that knowledge to derive demand functions, because knowing the marginal utility, how much utility changes if people consume a cup of coffee instead of not consuming that cup of coffee, that is sufficient. And we don't care about the absolute utility that they have after consuming the cup of coffee. We are only interested in increments. And that's why it's called the marginal revolution. So there, the expressive utility moves really into the background, and our modern concept of decision utility is not a cardinal concept, not a measurement in absolute values, but it's very much an ordinal measure. So it is a measurement in relative rankings. That said, that the absolute utility levels do not tell us much about the consumer's preferences. And that means that the utility functions that we use are only unique up to what is called an order preserving, so the ranking is preserved, an order preserving transformation, or also called a monotonic transformation. I will give you an example. So we had this original utility function, utility is equal to x times y. A monotonic transformation of that utility function would simply be to multiply the entire utility function with 100. And that will preserve the ranking. If you previously had one bundle that gave you a utility of 3 instead of 1, now that same bundle will give you a utility of 300 and the other 100, and the relative ranking continues to be the same. So this new utility function is a monotonic transformation of the other one, but it implies the same trade-off between alternatives of the individual. A picture is sometimes worth 1,000 words. And also in this course, we will use a lot of pictures to clarify concepts. And a convenient way to illustrate preferences in a graphical way is to make use of indifference curves. Now, indifference curves shows the combination of the set of all bundles between which the individual is indifferent. So all bundles that provide the same utility to the individual are connected in an indifference curve. And these are the familiar indifference curves. And if we talk of goods of which people enjoy the consumption, then the higher indifference curves are associated with a higher utility. So utility indifference curve U1 gives all combinations of X and Y, all bundles that give the consumer a utility of U1. The same holds for the indifference curve U2 and for the indifference curve U3. So on this graph, both commodities are good. So people prefer having more of them instead of less. So the utility levels associated with the indifference curve here are ranked U3 is a higher number than U2, and U2 is a higher number than U1. The slope of the indifference curve is negative because people like both commodities. So if they give up some units of Y, they need to be compensated by receiving more units of X in order to stay on the same indifference curve. So that makes the slope of the indifference curves negative. Again, it's not a restriction that we think of goods that people like to consume. We could also study pollution. Pollution is something that people do not like. They want to have less of it, not more. But if you want to study pollution, you can simply take the negative of pollution and consider the good clean air. And people like to have more clean air instead of less. So the indifference curves on the previous slide, they represent preferences that satisfy monotonicity. And monotonicity is defined as if you take a number delta larger than 0, then it means that if you get an increment of delta units of good X, then you will prefer the new bundle, you will strictly prefer the new bundle over the old one. So having more of a good is strictly preferred over not having that extra amount. So more is better. That's the short summary of the monotonicity assumption. And what it does in practice, it rules out thick indifference curves. As soon as you add a small number of units to one of the goods, to the bundle, then you end up at a different indifference curve and you don't stick at the same indifference curve. If that would not be the case, then you could add additional units to one of the goods and you would remain on the same indifference curve, making these indifference curves very thick. And it's an often used assumption that more is better, and it makes sense as long as you consider goods and not bads. But now you may object, you may say, wait a minute, I really like cake, but after 4 slices of cake, I'm quite full and I don't want more. So isn't it strange to assume that more is better? Now, there are 2 responses to that valid question. And one response is, observing that you are satisfied if you have eaten 4 slices of cake. You've reached your satiation point. One response is, okay, we assume that we always observe people's choices before they reach the point of satiation. That will get rid of the problem. Another solution is to assume that there is a free disposal, that suppose that you are served more than 4 slices of cake and you're not willing to eat more than 4 slices of cake. If there's free disposal, you assume that you can get rid of the additional slices of cake without any cost of effort. And I have a favorite example of this, that free disposal is an assumption that you may need in practice. And we go to the theater, and at the end of a show, the artist often receives a bunch of flowers from the theater. And now, monotonicity would assume that the artist is very happy with that. The more flowers, the better. But in practice, these flowers may be a nuisance, and actually he may not really like having these flowers because he has to bring them with him in the train or in the car or whatever. But as long as he can freely dispose of these flowers, then his utility will not decrease from receiving them, because he can just throw him to one of the audience member in the public. And actually, I don't make up this example. This is what often happens in practice. And this is from a newspaper where one of the employees of the theater asked these questions. Okay, what are the rules and what are the norms about giving flowers to the artist at the end of the show? And the response of the person, and this is the translation in English, is that you have to be aware that artists normally don't like flowers. They do like applause. So artists, they have can get enough of applause. So indeed, for applause, it holds the more the better. But this isn't true for flowers. So it ends with, but throwing the bouquet can of course also be prompted by a lack of enthusiasm to have to carry a bunch of flowers with them for the rest of the evening to the dressing room, the bus trip, and the artist cafe. So free disposal. And if you look at a theater show on the television or hopefully live, please pay attention what happens at the end of show. When the artist receives flowers, what does the person do with the flowers? Does he or she keep the flowers, or does he or she try to get rid of the flowers by, for example, throwing into the audience? Okay, so assuming monotonicity is innocuous as long as there's free disposal or people did not reach the satiation point. Now, one property of indifference curves is that they cannot intersect. So you cannot have a situation like in this picture where combinations of A and D, they're on the same indifference curve. So if you look at U1, you have to conclude that the person is indifferent between bundle A and bundle D. But then if you compare bundle D to bundle C, then you observe that bundle C has more units of X and more units of Y compared to bundle D. So monotonicity then leads you to conclude that the individual must strictly prefer bundle C over bundle D. Following the similar reasoning, you need to conclude that the person will prefer bundle A over bundle B. And now we've reached an inconsistency, because if the person is indifferent between bundles A and D, then he cannot prefer bundle C over D and bundle A over B, because also bundle B and C are on the same indifference curve and the person is indifferent between the two. So this shows you why indifference curves cannot occur, because once you draw them this way, you reach an inconsistency, and the inconsistency is shown here. And yeah, the nature of the inconsistency is that the transitivity axiom is satisfied. So if you strictly prefer C over D and A over B, then it should follow from transitivity that you strictly prefer A over D, but it shows from the picture that that isn't true because the person is indifferent between the two. Next concept is the marginal rate of substitution, and this is the measure of how negative the slope of the indifference curve is. So it's simply defined as the slope of the indifference curve, and given that we are on a particular indifference curve, we need to keep the utility constant. So this is why we have this vertical bar conditioning on the utility being equal to U1. So it's the derivative of y over x conditional on remaining on the same indifference curve. And that again is equal to the derivative of the utility function with respect to x over the derivative of the utility function with respect to y. And that's not that, well, the intuition is clear. So, for example, if the marginal rate of substitution is equal to -3, it means that you are willing to give up 3 units of y in order to get 1 additional unit of x. And you stay on the same indifference curve, you keep the same utility level. So you're willing to give up 3 units of y in order to get 1 extra unit of x. Then it needs to be that an extra unit of x gives you 3 times the utility of the 1 unit of y that you give up. And in total, you give up 3 units of y. So how about the substitution between products? In general, people like balanced consumption bundles. They like, if they organize a party, they like not to only have drinks, but also to have snacks. Because if you only have drinks, then you end up very drunk. So it's good to have a combination of drinks and snacks. And yeah, so if you would only have snacks at your party, then you would be willing to give up some of the snacks in order to have some budget for drinks. And the idea that people prefer to have balanced bundles is captured by the convexity of the utility function. So that's not a property of the utility function or the indifference curve. Now, what is the definition of convexity? Suppose that you are indifferent between 2 bundles x and y. Then it must be that if you take a mix of that bundle, of these 2 bundles, then you must strictly or weakly prefer the mix of these 2 bundles to each of the individual bundles. So in mathematical notation, it looks as follows. You are indifferent between the 2 original bundles. Now you take a combination of these 2 bundles. So if t is equal to 0.5, you take really the average of bundle x and bundle y. And you need, for any choice of t, you need to weakly prefer the resulting combination over one of the original bundles. Now, indifference curves are usually convex, so they're usually well-balanced bundles. So if you have 2 bundles here on the same indifference curve, so the bundle over here and the bundle that you observe over here, convexity implies that if you take a linear combination of these 2 bundles, so a dot here on the black line, then each bundle on this black line must be strictly preferred to either of the original bundles. So all points on this black line must be at least at a utility level equal to U1. And if the convexity is strict, these points must be on higher indifference curves than the indifference curve U1. So this is weak convexity. If we change the relation, weak preference relation here to strict preference, then we get strict convexities. And in case of strict convexity, you have diminishing marginal rates of substitution between the two goods. Okay, so then the question you may have is, okay, we have here the two-dimensional indifference curves, and then we have the utility function. How is the convexity of the indifference curve related to the form of the utility function? Again, a good question. So the result is that quasi-concave utility functions imply that you will have convex indifference curves. And that diminishing marginal utility, so the more you get of a good, the smaller the marginal utility of having still additional units of that good. Diminishing marginal utility doesn't ensure quasi-concave utility, so diminishing marginal utility also does not ensure that you have convex indifference curves. Now, what does quasi-concavity mean? Here I give an example of a quasi-concave utility function. So the utility function in three-dimensional space looks like a cone. So here you have the number of units of x and y consumed here at the bottom. And then on the z-axis you have the resulting utility level. So we get a three-dimensional picture. And each level is associated with a specific level of utility. So you can slice the picture on the left at a certain level, and doing the slicing you would get an indifference curve. So for example, if you would slice it around the yellow area where the utility is equal to 6, and then draw the two-dimensional picture, then you would get the indifference curve associated with the yellow line over here. And the same if you would slice it at a utility level of 2 or 4 or 8. So this is a quasi-concave utility function, and slicing it gives you convex indifference curves. Now, computing the marginal rate of substitution, we are given a utility function, so we can take the derivative of this utility function with respect to x and also with respect to y, and you get a marginal rate of substitution equal to y over x, which means that this marginal rate of substitution is diminishing in x, because if we increase x and at the same time the y decreases, so if we move along this indifference curve in the direction of an increasing x, then at the same time the y is decreasing, and we have a marginal rate of substitution that becomes increasingly smaller. So the indifference curve becomes shallower and shallower as long as we increase the value of x. Now, a next question that you may have is, can you give an example of a utility function or an indifference curve that is not convex or not quasi-concave? That's a good question, and I will present you an example. So I will switch to the tablet, and this is the indifference curve that you just observed, and we can, if we have a situation like this is an indifference curve that is not convex, and you can see it as follows. Suppose that you have two points on this indifference curve, point x and point y. Then convexity says that if you have a combination of these two bundles, then it must be at least at the same indifference curve, and if it's strict convexity, it must be on a higher indifference curve. And you can see that if you combine these 2 points over here, these two consumption bundles, then we have situations, consumption bundles on the connecting line that are on a lower indifference curve. Like for example, this point over here will be on an indifference curve that looks like as follows, and this U2 is smaller than U1. So this is an example of non-convex indifference curve, and it's also generated by a utility function that is definitely not quasi-concave. So another open question that you may have, I gave you a formula for the marginal rate of substitution, but how did we arrive at that expression? Now, one way to derive this is to observe that in the indifference curve, the utility level is by definition constant, such that we can write the utility function at an indifference curve is equal to a level u1, which is a number, and we take the total differential of this implicit function on the left hand side and the right hand side. Well, on the right hand side, the resulting expression is 0 because this is a constant, and on the left hand side we have the expression, the partial derivative of u with respect to x times dx plus the partial with respect to y times dy. This should equal 0, so we can rewrite this expression as follows. And now we observe that on the left hand side we have the slope of the indifference curve at a certain utility level u1 must equal the derivative of the utility function with respect to x divided over the utility function derivative with respect to y, which is our definition of the marginal rate of substitution. So this proves to you that indeed the negative of the slope is equal to the marginal rate of substitution. Finally, I'm going to show you 3 utility functions that are related and that have a prominent role in this course because one, they are fairly easy to work with, and second, together they represent all relations between goods more or less that are useful to consider. And we start out with the Cobb-Douglas utility function, which has as a general form x to the power alpha times y to the power beta, with alpha and beta being just numbers, but they need to be larger than 0. And if you take the derivative of this thing with respect to x and divide by the derivative with respect to y, then you get the marginal rate of substitution. And the typical indifference curves of the Cobb-Douglas function look as follows. So you can see nice, strictly convex indifference curve, which means that the goods, if they take away some of units of good y from you, then you want to be compensated by getting additional units of good x. That's the first one. The second utility function is the case where the goods are perfect substitutes. So think of the textbook example of having Coca-Cola in bottles of 1 liter and in bottles of 2 liters. If you consume a lot of cola anyway, you don't care that much whether you have 1 liter bottles or 2 liter bottles, especially if the price of the two reflects the difference in volume. Similar thing, if you only care about writing and not the color of your pen, then you are different between black and blue pens, and you buy whatever pen is cheaper. Now, in case of perfect substitutes, the utility function has the linear form alpha times x plus beta times y. Alpha and beta also here are positive numbers. And the marginal rate of substitution is easy to compute. It's just alpha over beta. Importantly, in the case of perfect substitutes, the indifference curves are not strictly convex. They are weakly convex, so they're still convex. Straight lines are convex indifference curves. But the marginal rate of substitution doesn't change if you move along one of the indifference curves. The slope of this indifference curve is at each point identical, no matter how much x or y you already consume. So, yeah. Now, in the third instance is where we have the other extreme. We have perfect complements, where goods are really consumed into fixed proportions. So, coffee and milk, if you have milk in your coffee at least. And then you have a utility function that takes the form minimum alpha x or beta times y. Again, alpha and beta being just numbers larger than 0. So for example, if you have 3 units of coffee and 1 unit of milk to make a cappuccino, then your utility function will be the minimum of x times 3 times y, with x denoting the number of units of coffee and y denoting the number of units of milk, meaning that if you have 1 coffee and 3 units of coffee and 1 unit of milk, you can brew 1 cappuccino, gives you a utility of 3. But if you have 3 units of coffee and 2 units of milk, that additional unit of milk doesn't buy you any utility, because still you can only make 1 cappuccino. And in the end, you derive your utility from the consumption of the cappuccino. So in this case, the consumer will always consume cappuccino and milk in a ratio 1:3. And there are no substitution possibilities. So the marginal rate of substitution is plus infinity as long as beta I is larger than alpha x. So if you have a lot of units of y and not enough of x, then you can reduce your units of y without decreasing your utility. So the marginal rate of substitution, the slope of the indifference curve is minus infinity here. So the marginal rate of substitution at this part of the utility function is plus infinity. Now you consume them in fixed proportions, which is denoted by the dotted line over here. Then the ratio is just right. But then if you receive additional units of x without receiving additional units of y, it doesn't help your utility. You cannot make more cappuccinos. So your indifference curve is perfectly flat, and the marginal rate of substitution at this part is equal to 0. The preceding utility functions are all special cases of the more general SES utility function, the constant elasticity of substitution utility function. And that utility function has the following form: for values of delta smaller or equal than 1, but unequal to 0, this is the form, and if delta is equal to 0, the SES utility function has this form in natural logarithms. So, given this utility function, you can also compute the marginal rate of substitution by taking the derivative with respect to x and y. And we define sigma to be 1 over 1 minus delta, which is the substitution parameter of the SES utility function. Now, how do we translate this utility function to the more specific cases that we observed before? We can do so by plugging in specific values for the parameters. So for example, if you take sigma equal to 1, which implies that delta is equal to 0, and we are in this case over here, then you can readily see that this utility function with the natural logarithms is just a monotonic transformation of the utility function that we observed before for the Cobb-Douglas utility function. Now, in the case of perfect substitutes, the sigma is equal thus to plus infinity. And if sigma is equal to plus infinity, that implies that delta must be equal to 1. And if delta is equal to 1, we are in the situation of this utility function plugging in the value delta equal to 1. We arrive at the expression alpha times x plus beta times y, which is the expression indeed for the case with perfect substitutes that we observed before. And then finally, with perfect complements, sigma is equal to 0. And if sigma is equal to 0, it means that we need to take a value of delta that is minus infinity, And if delta is equal to minus infinity, we arrive at a limiting case with the minimum utility functions that we observed in the previous slide. For a derivation of that, I will refer you to the lecture notes that you can find online. And it's easy to see why this is called the constant elasticity of substitution utility, because for each of these specific cases we have a constant value of sigma, the substitution parameter, and with perfect substitutes there are infinite, you can substitute in an infinite way more or less, so the sigma value is equal to plus infinity. And in case of perfect complements, no substitution is possible at all. The SAS utility function is a homothetic utility function says that the marginal rate of substitution only depends on the ratio in which you consume x and y. So the marginal rate of substitution is a function of the ratio y over x, as you can see here. You can also see it in the previous slides that for the Cobb-Douglas also marginal rate of substitution is a function of y over x. Here it doesn't appear at all, and here it's also in fixed proportions. Now, what is a homothetic preference? A homothetic function is a monotonic transformation of a homogeneous function. Next question, what is a homogeneous function? A homogeneous function is defined as a function that if you multiply the element x, all elements in the vector x with a common factor t, then the function value will increase with t to the power k, where t denotes the degree of homogeneity. And we will come across these homogeneous functions quite a bit in this course. Now, it works better with an example, so let's give you an example. Here we have our familiar utility function, and the homothetic function is a monotonic transformation of a homogeneous function. This is a homogeneous function because if we multiply both the elements x and y with t, then we arrive at t squared times xy, so we arrive at t squared times the original function. So this original utility function is homogeneous of the degree 2. And the function h is a monotonic transformation of this homogeneous function because it simply adds 1 to each value. Now, each homogeneous function is a homothetic function as well, but that doesn't hold vice versa. So not all homothetic functions have the homogeneity property. So you can see it in this function. This function is a homothetic function, but it's not a homogeneous function. And all homothetic functions, although they're not all homogeneous, they preserve the nice properties that the implicit trade-off by the function depends only on the ratio in which the two goods are traded and not on their absolute values. So the marginal rates of substitution remain only a function of the ratio y over x. Now, why is that useful? I will give you an example. So this is a graph of sum and difference curve of a homothetic function. And you can see that this is a homothetic function in the sense that if you consume the goods I and x in the ratio 2 to 1, then at all consumption bundles with this ratio, the marginal rate of substitution, the slope of the indifference curves, is identical. And also, if you consume y and x in the ratio 1 over 2, then for all those combinations, so all these combinations for which that hold on the red line over here, the marginal rate of substitution is the same. So the slope of the indifference curves that at the point where they intersect with this red line are always identical. which means that the indifference curves for higher utility are simply copies of those for a lower utility, which in turn implies that the results that you obtain for one level of utility carry over to other levels of utility. So we will get to budgets in the next lecture, but let's just give an example here. Suppose that you have a budget constraint that allows you to consume up to 3 units of good X or 5 units of good Y at the prevailing prices. Then given your utility function, you might find it optimal to consume X and Y in a ratio 2:1. And now suppose that your income changes. Now, and the prices of good X and Y are unaffected. So the slope of the budget constraint stays the same. With this higher income, you will continue to consume goods Y and X in the same ratio. Of course, your income has increased, so you will consume more of each of these goods, but you will continue to consume them in a ratio 2:1 because your underlying preferences are homothetic. That also tells you about the restrictions that homothetic preferences impose, because they don't allow you to change the ratio in which you consume two goods when your income increases. But when dealing with empirical data, this is pretty useful, because if you make this assumption that the underlying preferences are homothetic, you can group together households with different income levels, because the prediction always is that they will, other things being equal, will consume X and Y in the same ratio despite their income being different. That brings us to the end. Thanks for your attention, and following this chapter and following this lecture, you can work on the exercises from the book. Thank you very much.